Hello everyone, my name is James Nicholson and my project is called MBTA Arrivals. MBTA has a great train prediction API, but it returns data at a high velocity and needs processing to become useful and readable to humans. The goal of my project was to create a streaming data pipeline that processes predictions from MBTA about train arrival times and departure times um, and displays them in a human readable way. So as you can see here, the architecture kind of revolves around Akka. So the events are coming in, the prediction events are coming in at about 1 per second. They're being looked at and stored in an in-memory map to keep track of which predictions we've seen so far, and if another prediction comes in that has been seen before, then that information is displayed to the user, showing whether or not the train is running early or late. So a new prediction comes in and it'll be displayed to the user in the console in a human readable way, saying X train is predicted to arrive at X time. But if a prediction comes in that's already in the in-memory map, then it's going to say that X train is now running 10 minutes late or 5 seconds late. And so that's the gist of it. And now I'll quickly go over the implementation. So the Python script was very simple, just using regular expressions to basically just pull out the JSON from this downloaded data. This is the raw data from the API. You can see that the protocol used by the MBTA API is called a server sent events. Akka is gonna want something that's more machine readable, and so it's a lot easier to kind of create a source from JSON in Akka than just kind of more unstructured text like this. So I used Python to kind of parse that into just JSON events here. Here in my main function, you can see that I'm creating a source, a flow, and a sink, and those are the main things in Akka streaming. And when you combine those three things, you have what's called a runnable graph. You can see here in the flow, it's being throttled to 1 per second. That's taking advantage of the sort of reactive stream part of Akka, which is a way for different parts of a runnable graph to communicate with one another and kind of speed up the flow of data or slow it down without blocking and without sort of breaking the asynchronous nature of the stream. And so the way this will get started, obviously, is just to do sbt run. Here we can see the data starting to flow in. Train R547914 will arrive at stop 70063 at this time. So these are all new train predictions coming in when it says train will arrive at stop XYZ. When you see it saying train is running 10 seconds late at stop Y or Z or A or B or C, that's when it's encountered an MBTA prediction that's already in the memory map. So yeah, it's a pretty simple application, but it was a great way to learn more about Akka and reactive streaming and all of that. So thank you for listening, and let me know if you have any questions.